Today we're going to continue looking at section 1.5. So we are going to be identifying midpoints of segments, identify bisectors and trisectors of segments, and angles. All right, so if we start looking at some examples here, this first one, we are told that y is the midpoint of the segment xz. Notice that I don't see a picture at all in this problem. I just see some given information. So it would be a good idea if we sketch a picture and mark up the picture to then help us in the problem. So we have a segment XZ. So I'm going to draw a segment XZ. And if y is the midpoint, well, we learned that the midpoint is going to then bisect the segment. So that means that we have two smaller congruent segments. So I get to mark them the same. So I put one tick mark on each of those. We're also told that segment XY is represented as 3x plus 2. So I'm going to mark that in my picture. I'm told that the segment of XZ, which is that whole entire segment, this is a length of 20. We're trying to find the value of x and then the length of those two smaller segments. So there's a couple different ways that we can tackle this. Notice that if we have 3x plus 2 is being represented as xy, well then technically because we have congruent segments, I know that yz is also 3x plus 2. So technically then, because the entire segment is 20, I can add up those two little pieces and I can then set that equal to that entire length. So that's one way we can set it up. Now, if I go ahead and solve, notice we've got some like terms. So there ends up being 6x's. And then 4, that still equals 20. I'll subtract the 4 over. And then I'll divide by 6. And so that is not going to divide into a nice whole number. That's fine. I'm going to keep it as a fraction, but this fraction does simplify down. So 16 over 3, or I'm sorry, 16 over 6 both have even numbers. So I'm going to divide them by 2. And so I found x to be 8/3. All right. Another way you could have done that is the fact that because 20 is the entire length and y is the midpoint, it's cutting it in half. So then hopefully we're okay with the fact that each of those little pieces have to be 10. So that's actually the second half of what they're asking for. They're looking for the length of x, y, and y, z. So right off the bat, I really didn't have to do too much algebra. I just know that both of those are going to be a length of 10. So technically, we could have found that first. And then another way for us to solve for x is we could have just set 3x plus 2 equal to 10. So notice that then I could have subtracted 2 and then divided by 3, and we would have gotten the same answer of 8/3. So two different ways for us to do that just because we knew the entire length of that segment, cut it in half because we had a midpoint and got us each 10. All right, in this next one, we are given angle XYZ is a 61-degree angle. So that is this entire angle if you follow the letters. So this whole entire angle, sorry, my pen has not been my friend today. So this whole entire angle is 61 degrees. I'm going to start marking up the rest of my picture. Angle 1 is being represented as 2x plus 1. Angle 2 is being represented as 3x. Angle 3 is represented as 8x minus 5. So if it's asking, has the angle XYZ been trisected? So trisect, remember, tri, like triangle or tricycle, we want 3 pieces. And so in this case, we want 3 congruent pieces. So the only way for us to figure out if it's trisected is we have to figure out what x is, so then we can find the measure of each of those small little pieces. So the fact that all three of those smaller angles are forming the big angle of XYZ, and we know that that's a 61-degree angle, I can add up all the pieces, set it equal to 61, and that's how we can solve for X. All right, so 2x, 3x, and 8x. Well, 2 and 3 is 5, 5 and 8 is 13. 1 and negative 5 will give us a negative 4. So I'm going to add 4. And then I'm going to divide by 13. And so I'm getting a value of x to be, what, 5? All right, so that's not my final answer. I want to know, do I have a trisected angle? So that means I want to know, well, what's the measure of angle 1? What's the measure of angle 2? What's the measure of angle 3? So I'm going to start substituting 5 back into each of those smaller little expressions. So we'll have 2 times 5 plus 1. We'll have 3 times 5, and we'll have 8 times 5 minus 5. 2 times 5 is 10, plus 1 is 11. So angle 1 is 11 degrees. 3 times 5 is 15, so angle 2 is 15 degrees. We've got angle 3 is 8 times 5, so 40. 40 minus 5 is 35. So as we can see, each of those angles are different measures, and so because they are different measures, our answer is no, angle XYZ is not trisected. If they were all exactly the same measure, well then yes, we do have a trisected angle, but in this case, we do not. All right, in this next one, it's telling us that the segment BC is divided by point Z in the ratio of 5:3 going from the left to the right. So once again, we don't have a picture, so I would suggest that we sketch a picture to represent this problem. So here's the segment BC. Point Z, if it's splitting it into the ratio 5:3. So remember, we've talked about ratios in the past. This is going to be represented as 5x. This is going to be represented as 3x. Because they are not the same length, Z cannot be in the middle. Because I'm talking about going from left to right, that means since 5 is on the left, I want to have a segment bigger on the left than I do on the right. So that means I need point Z to be closer to C than it is to B. So that's why then that segment BZ is really then 5x, and then ZC would be 3x. I'm telling you that BZ, this segment, is a length of 10. We want to find the length of the segment ZC as well as the whole entire segment of BC. So hopefully we notice that with all of the pieces that are marked up, I happen to have two things representing the exact same segment. BZ is being represented as both 5x as well as 10. So when two things are representing the exact same segment, that indicates that I get to set those two things equal to each other. So then if I start dividing, I find out that x is 2. And so then that's going to help me figure out then what segment ZC is. Because I know it's represented as 3x, I now get to plug in 2 for x. So that tells us that we have a length of 6 for that segment. And BC is the entire segment. So it's made up of both BZ as well as ZC. So if I know that 10 is BZ and we just found 6 to be ZC, I can add those two pieces together to get the whole entire piece, which then would have to be 16. Here's another one where I would suggest that we sketch a picture. So it says the segment RS is divided by points A and B in the ratio 2 to 3 to 7 from left to right. So I'm going to sketch a segment, call that RS. We have 2 more points on that segment A and B. So if we look at the ratio, 2 to 3 to 7, going from the left to the right. So we want a small segment of 2x, followed by a little bit bigger of a segment to be represented as 3x, followed by an even bigger segment, which is 7x. So that means that I want A to be close to R, so I can call that first segment 2x. Then I want to have a little bit bigger of a segment, so I have to put point B there because then this is 3x. And notice that then the longest segment there is 7x. They're telling us that the entire segment RS is being represented as a length of 40. So based off of this picture, if I'm giving you the length of the entire segment and I have 3 little pieces that put them together give you the big segment, hopefully we're okay with, I'm going to add each of those little pieces and set it equal to the entire length of the segment RS. 2 and 3 is 5, 5 and 7 is 12. So we'll have 12x equals 40. So we'll have to divide by 12 to get x. Once again, that's not going to give us a perfect number, but we can definitely reduce down that fraction. Both of those are divisible by 4. So that means that this x value is really 10/3. But that's not my final answer. They're asking for the length of the segment AB. Well, AB is being represented as 3x. So 3 times now my x value, which is 10/3. Well, 3 times 10/3 is going to give you a length of 10. So that would be my answer. All right. If we're talking about angle bisectors and trisectors, here's this one. It says, given that the measure of the angle ABC, so this big angle ABC, this whole thing, I'll make that, is being represented as 10x minus 24. I'm telling us that the angle ABD, so follow letters, ABD is this angle over here, that's 2x. And they're telling us that the ray BD is bisecting that big angle of ABC. Now remember, bisect, so like bicycle, binomial, we're thinking about 2. So if it's 2 congruent pieces, that means that this little segment, I keep saying segment, I'm sorry, this angle and this angle, so those 2 smaller angles are going to have to be congruent. And so if I know that angle ABD is 2x, well, that means now that angle DBC is also 2x. They want us to find the measure of that angle ABC. Nowhere in this problem have they given us any specific numbers. They've just given us expressions. So we have to see what can we do with these expressions to then solve for x. Since angle ABC is 10x plus 24 or minus 24, and we have 2 smaller angles inside that together form that angle, hopefully we're okay with, I'm going to take those 2 little angles that are congruent. If I add them together, that's going to represent that entire angle, which is 10x minus 24. So combining those on the left gives us 4x. Now I want to move x's to the same side. So I'm going to subtract the 10x. That gives us negative 6x equaling negative 24. I'm going to divide by negative 6. And so we get x to be positive 4. So to find then the measure of angle ABC, well, we're going to plug that back into the expression. So ABC is 10 times now 4 minus 24. 10 times 4 is 40. When I subtract 24 from it, I'm going to get an answer of 38. We're talking angles, so I'm going to put the degree symbol there. So 38 degrees. All right, here we have an error analysis problem. So Jenny is unsure of her answer to one problem from a recent assignment. If you agree with Jenny's work on a problem, you're going to explain how you know her solution is correct. If you disagree with Jenny, you're going to identify the mistake and solve the problem correctly. So if we look at this problem, it says if the segment EH, which notice is this entire thing right here, if that whole segment is a 56 in length, they want us to find x. So notice that that big segment was broken into 3 smaller pieces, 8x, 5x, and 2x. Notice that I agree with Jenny as far as we need to add those pieces together to get us that entire length. but hopefully you disagree with Jenny because of this number right here. What she set it equal to was 180. That's not what the length of EH is. EH is really 56. So I'm going to disagree because the length of EH is 56, but Jenny set the length equal to 180. So just be careful. We are not talking about straight angles here. We're talking about segments. So that's why 180, if she was thinking degrees, wouldn't work in this case. So we explained why we disagreed, and now I'm going to solve it correctly. So like I said, I agree that we want to add up all of those three pieces, but now we want to set it equal to what the actual length is. So we want to set it equal to 56. So if I combine my like terms, 8 and 5 are 13. 13 and 2 is 15. So we have 15x equaling 56. Notice that all it's asking for us to do is to find x. So I just have to divide by 15. Okay, it's not going to be the prettiest number. So if that simplifies down, we'll simplify it down. 56 over 15, though, is not going to reduce. So I would honestly then just leave it as a fraction. So that would be my answer. Okay, so once again, that's us identifying midpoints of segments and looking at bisectors and trisectors of both segments and angles.